Okay, when we added and subtracted with fractions, we needed to make sure that they had common denominators. When we multiply or divide with fractions, everything has to be in fraction form. Okay? Everything has to be in fraction form. So the basics are, we see a fraction like 3/5 times 1/4. Okay? When I see a fraction or a multiplication problem using fractions, I don't have to worry about do they have common denominators. In fact, I just need to make sure they're in fraction form. And fraction form essentially means A over B form. I have a numerator, I have a denominator. It doesn't necessarily have to be numerator smaller or a regular fraction. Irregular fractions would work just as well. But in this case, they're both regular, and I can essentially just multiply straight across. 3 times 1 is 3. 5 times 4 is 20. And as long as 3/20 is in simplest form, then that's our final answer. Alex. The answer always has to be in the simplest form. But in order to do the work, you have to make sure that these are in fraction form. Okay? This is page 237. Okay? Sometimes we get just like always, anytime you multiply and you have negatives, when you multiply a positive times a negative, you're going to get a negative. Okay? Now, there is a little trick that we use that helps us simplify these before we get to our final answer. And that is where we, yes? Well, yeah, we look diagonally. Okay? And I look at the 7 and the 21, and I ask myself, is there anything that I can divide them both by to kind of reduce them a little bit? Chris? 7. I say, okay, there's 1 7 there, and there are 3 7s in 21. I look diagonally the other way, between a 4 and a 10. I can divide them both by 2. That's a 2, and that's a 5. So a 1 times a 2 becomes a 2. 5 times a 3 is 15, and since it's a positive times a negative, it's a negative 2 15. The multiplication facts remain the same. There's no confusion there. Okay, positive times negative gives you negative. Can you get the right answer if you don't do all this reducing? Sure, but then you're going to get 28 over 210 if you don't do any of this reducing. Which, if you do the reducing, if you simplify correctly, you will get 2 over 15 because they have 14 in common, but you may not recognize that just by looking at it. Do you understand? So it's always better off to do it ahead of time. Okay? Any questions? Want to try a couple before we get to putting variables in there and everything? Question? The first one? Yeah, so good question. We'll go back. And he said, for this one here, when I look diagonally at the 3 and the 4, there's nothing there to divide them both by except for 1. Same thing here. That's why when we just went straight across, it was already in simplest form. If this is not, chances are you missed something. You could still fix it. Okay. Okay. Let's do this. 2/3 times 7/8 negative 5/12 times a 3/10. Try those two. Okay. So the first one, anything in common with the 2 and the 8? 1 there, How about 7 and 3? So 1 times 7, 3 times 4, 7 over 12. How many got it? Okay. Over here, 5 and 10. 12 and 3? Yes. We'll get to that in a minute. 3 and 12 is 3. 1 times 1, 4 times 2. And since I'm multiplying a negative times a positive, just make it a negative 1/8.
On the first one, you could also be 14 hours, but it simplifies is 1424 to simplify.
Right, and that's what we said. It's probably easier for us to do it here than it is for us to wait till the end. Okay? So it worked out okay, because Joel, that was where I said here, okay? Which one? This one. If I didn't do all this stuff here, I would have gotten 28 over 210. Right? So I'd rather stick with the 215 than the 28 over 210. You know what I mean? It just makes things a little bit easier. All right? Any questions there? 4 and 7/8 times 5 and 2/3. Okay, rule number 1, everything has to be in fraction form. Are those in entirely fraction form? No. So now I got to put them into impropers. 4 times 8, 32 plus 7 over 8. And 15 plus 2. Okay. Diagonally between a 39 and a 3. 3. Okay. So 17 and 8, really nothing. So I'm going to be stuck doing 13 times 17, which is 91, 221 over 8. What do we do from here? Yeah, we still have to simplify it. We'll say, well, it's in fraction form. Well, your answer has to be, once you get to your answer part. So here, if you're not sure, then just set it up like a division problem. Okay, but don't put the decimal in, because the fraction is going to represent the decimal part. 8 into 22, 2. And then 8 into 61. 7 is 56. How many are left? So your final answer, 27 and 5/8. Nope, we didn't put a decimal in because remember, you're either a decimal or you're a fraction. You're not both. So we just wanted to find out how many whole times the 8 goes into 221. That's where we came to 27.
Oh, let me put that down. Wait, can you repeat that?
We needed to find out how many times the 8 went into the 221. How many whole times? And that's what we found when we said the 27. Once I got my remainder down here, that remainder ended up being my numerator. Okay, try this one. -3 and 2/7 times 1 and 1/2. Again. 21 plus 2, 23 over 7, that's a negative. 3 over 2. Okay, unfortunately for us, we don't really have it, right? 23 times 3, 69 over 14. So 14 into 69, 4 times is 50, which is 13. So -4 and 13/14. Yep.
Go around. I think I need to see someone because I keep hearing things. Like it'll be dead. No, like it'll be dead quiet, and I'll hear
Maybe it's the spirits.
No, that's not funny. You didn't have to kind of.
Okay. Here's another thing I want you to look at. Before you even start, we can round these to estimate where our answer should be. When we have mixed numbers, we usually round them to the nearest whole number. And the fraction that we're looking for is half. That's the benchmark. So if that fraction has a value of half or greater, we'll round up to the next whole. But if it's less than half, we stay. 1/8 is definitely less than half. We'd round to 4. And 2/3 is more than half. We'd say times 2. So we should get something in the ballpark of -8. Positive times negative. So now we go through and we put everything in fraction form. 33 over 8 times a negative, what, 5/3? Okay. So again, I'll look diagonally. 33 and 3 both have 3 in common. There's 3 there and 11. 55 over 8. 8 into 55. 6 times is 48. 7 left, and that's a negative because it's a positive times negative. Is that close enough to -8 where I probably, shouldn't have to look too hard at it again? Yeah, I think so. At least it gives you. Five six is in fraction form, but 8, anytime I want to put a whole number into a fraction, has to be what? Or 1 over 8. Six and 8 by 2, so that's a 4. That's a 3. So a -20 over 3 is a 6 2/3. -6 2/3. 3/5. Okay. Now, algebra, you might want to kind of take a peek at this as well, because this is something you might see as well if we haven't seen it already. But it's a 9. 3y over 4 times a y to the 5th over 9. So everything is in fraction form, so we're good to go there. Now we'll just look diagonally. We will treat the integers separately than we'll treat the variables. So when I look at a 3y and a 9, I can divide them both by 3. So that'll make that just a 1y, and that'll make that just a 3. Notice I didn't do anything with the y. Okay. Over here, y to the 5th and 4. Can't do anything because that's just like a 1. So when I multiply y times y to the 5th, I get y to the 6th. 4 times 3 is 12. So y to the 6 over 12. There is. There might be. But I can't go into this variable and say, oh, that's 6, that's to the 6th power, and that 12, they both have 6. No, I can't touch the power with a regular integer. Yes? Essentially, when you multiply them, you end up adding them together. Okay? Three z to the 5th over 25. 2z to the 4th over 15. Diagonally, 3 and 15. That's a 1. That's a 5. Any variables? No. 25 and 2. So 2z to the what? 4 and the 5 give you the 9. When you multiply them, you add them together. 25 times 5. Yes, ma'am. Yep. Remember this? Shh, watch. Remember this? 2 to the second times 2 to the third. Okay, watch. Watch. What is 2 to the second? And the 3-headed monster? Okay. Equals 2 to the what? What is 32? If 2 to the third is 8, right? 2 to the fourth is 16. 2 to the fifth is 32. What happened with the 2 and the 3 to get the 5? We added them together. So even though we're multiplying, we will add the powers together to get the 9. Okay? So that's why it makes sense when we look at the powers of 2.